And we're back. Special segments in a circle. All right, another problem looks very similar to the problems I showed you in the previous video, so I'd like you to jot this down, hit that pause button, give it a shot, see what happens. All right, I'm going to assume you have tried it. So let's compare notes. I see two secants meeting on the outside. So I would write the part on the outside 2 times the whole length 10, right? 2 plus 8, 10, equals the part on the outside x times that whole length of x plus 19. So here it is. 2 times 2 plus 8, or 10. Remember that whole secant length is 2 plus 8, 10. So 2 times the whole length of 10 equals x times the whole length of x plus 19. So 2 plus 8, 10 times 2, 20. Distribute the x, we get a quadratic. So to solve a quadratic, subtract 20 from both sides, get that 0. Some of you know how to factor. If you know how to factor, this is factorable. If you don't know how to factor, you can always rely on the quadratic formula. So there it is, and I'll slide this up a little bit. I know you can hit the pause button, so I'm not going to wait too long here. You can pause and look and follow along. And down at the end here, you'll notice I got my two answers, x equals negative 20 or 1, but I crossed off that negative 20. Why? Because x is the length of a segment. Can't be negative. So the only answer that makes sense on this one is that x equals 1. Okay, here's another one to look at. And I'll ask you to try the same thing. Pause, try to solve it. All right, so my thinking would be, I see two secants meeting on the outside. So the part on the outside, 4, times that whole secant length, which would be 2x minus 1 plus 4, or 4 plus 2x minus 1, is going to equal the part on the outside x times this whole length of 9 plus x, or x plus 9. So that would look like this. Part on the outside 4 times the whole length, which was the 4 plus the 2x minus 1, equals the part on the outside of x times the whole length of x plus 9. I combine my like terms, 4 minus 1, 3. I distributed the 4 on this side and the x on this side. Quadratic, so get everything on one side. I subtracted 8x from both sides, which is why there's now only 1x here. I subtracted the 12 from both sides, which is why there's a minus 12 over here. That got me my 0. So these are my ABC terms for the quadratic formula, which looks like this. And once again, I got two answers, and sometimes that's fine, but in this case, one of them was negative 4. And when I look at that picture, I know this segment length can't be negative 4. So the only answer that makes sense is x must equal 3. Okay, last thing I want you to try. This is circle C. This is the center of the circle. And I want to know what x is. So why don't you hit pause there and see what you get. All right. So I made this last one because a common mistake I see students do is this. They'll say the part on the outside times the whole thing, so that's tangent, so 4 squared, equals the part on the outside times the whole thing, and they write x plus 3. And that is going to get you the wrong answer. Sorry, that wasn't visible. That's going to get you the wrong answer. I'm going to zoom out a little. Because this theorem we've been working with applies if you have two tangent segments. Two tangent segments would be the ice cream cone theorem. Those are just going to be equal. But otherwise, we've been using it and we proved it will work if you have two secants meeting on the outside or a secant and a tangent meeting on the outside. This picture is neither. Now, what should we do? There are two ways we can figure, well, at least two ways that I know of to figure this out. One thing we could do is we could turn this picture into a tangent and a secant meeting on the outside by extending this. And if I extend that, now, since this radius is 3 and I know this radius is 3, now I can say outside times the whole thing, so 4 squared equals outside times the whole thing. That whole thing is x plus 3, x plus 6. This will get you the right answer. Here's the other way maybe some of you are thinking. How about instead of adding that radius, how about I add this radius? A radius to a convenient place, a point of tangency, that's going to be a right angle. And I know how long that radius is. Right triangle, legs are 3 and 4. Could I figure out the hypotenuse? I shouldn't use C because that's already in the picture. That might be confusing. Let's call it D. 3 squared plus 4 squared equals D squared. Of course we know what it is. It's a triple. D is 5. And if this is 5, part of it being 3, x must be 2. And that is the same answer you'll get if you solve this equation. So just be careful. Make sure this idea of outside times the whole thing is only being applied in the right situations. It's either when you have two secants meeting on the outside or when you have a tangent and a secant meeting on the outside. That's it for today.